All right, guys, so in the previous video, we had pin 13 turning on, but we had that LED that was just integral to the Arduino. So now we're going to hook up an external LED. We're going to make use of a current limiting resistor, but we also have to go through the actual breadboard. So let me show you the diagram that they have on the Lego site here. Okay, so they're showing here that on the breadboard, there is continuity on the top and the bottom there. So we have continuity all the way across the top on both of the legs. So you'll see that there's a blue and there's a red there. And so each of those guys will be like a bus bar. So one will be the negative and one will be the positive. We'll make the red the positive and the blue the negative there. And then within the actual breadboard, you can see that right here, we've got these lines. Let me see if I can make this a little bit bigger. So this line right here is literally just a piece of metal. So underneath the breadboard, there is a piece of metal that has a spring action. And when you take your terminal and you put your jumper terminal in there, then it will spread the metal apart and it'll bend in and grab your little lead there. So there is metal right across here, but there's no continuity. So continuity means that there's no connection between those 2 points, but meaning that there's no connection between these terminals right here, being these 5 terminals, and these 5 terminals on the other side. So the ones on the top and the ones at the bottom are completely separated or completely isolated from each other. Okay, also the ones beside each other. So this guy right here and this guy right here, they don't have continuity either. So the only thing that has continuity is this up and down connection on the top and the up and down connection on the bottom, meaning that all 5 of these terminals have connections, and then these 5 terminals have a connection. So be careful when you're hooking up components. Oftentimes in my class, the guys are putting in components. They will put them like one lead right here and one lead right here, and they essentially just short out that component. Okay, also be careful here in that if you have your positive and your negative for your power supply, the Arduino does have protection in it, in that if you short it out, it will turn itself off, but it's not a good idea to be shorting out your Arduino board. So be careful of any shorts that you create between those 2 bus bars there. Let's bring up the actual breadboard and I will show you what I'm talking about here. So let's see, you need something to point with. So this guy right here, so this rung right here, all the way along here is the negative bus there. And all the way along to the other side, you have continuity, meaning that there is a big ass piece of metal that goes right across from here to here and provides you with that continuity there. Okay, we have another long piece of metal that goes from here over to here, okay, meaning that we have the negative bus and the positive bus. On the other side, we also have a negative and a positive bus. So each of these guys you can see denoted with this line going right across. There is continuity all the way across on the bottom there. So you can set up either the top or the bottom as your positive and your negative supply, right? Positive being 5 volts, negative being the ground. And then with each of these guys, these 5 terminals right here, they have continuity in that this, and this all have continuity. They don't have continuity with the adjacent pin though. So be careful because it is hard to see. If you're coming in on an angle, you may think that you have a component in on the same point, but essentially it's off by 1, just like that. Okay, so each of these guys in a row have continuity, but there's no continuity between the adjacent rows here. There's also no continuity between these bad boys down here and these guys on the top there. Okay, so we'll see when we hook up our circuit that we need to keep that in mind there. So what I'm going to do is I'm going to provide 5 volts to the positive. So again, you have to kind of hover over the Arduino to see where the 5 volts is. So there's my 5 volts right there. And I'm going to bring that into my positive bus right there. And then I'm going to bring any of the grounds. So I have a number of ground connections there. So I'm going to bring the ground right here, and I'll just choose green for that. And I'm going to go into the negative bus there. So now I got 5 volts that's available right across those 2 bus bars there. Okay, then I'm going to create a circuit where I've got an LED in there. So I'm going to come from the positive bus, and I can grab from the positive bus anywhere along here, right? So I can just arbitrarily choose right here, and I'm going to go into this guy right there. Okay, then I'm going to put in my LED. Now, if you take a look at the LED, now you can put the resistor in first, or you can put the LED in. We're going to make a series circuit in that they're both going to be in line with each other. But when you take a look at the LED, I don't know if you can just make it out there. Let me put it over here so you can see it. There are two leads. Easy now. There's two leads on that guy. So you might just be able to make out that one is a little bit longer than the other one there. Okay, my autofocus is a little bit messed up. Let me try manual focus so we can see what we're doing there. Okay, so let's see if I can put it on my fingers here. Okay, so you can just make out that one of those leads is a little bit longer than the other one. The lead that's longer is going to be the positive there. So a diode is the same as an LED in that it has to have the right polarity. So we have to have positive to the anode and negative to the cathode there. So the longer lead is going to be pointing towards the positive. I'm going to put my resistor in next. So I'm putting in a 220 ohm resistor. So you can use, in your kit, you may have 220 ohms, you may have 330 ohms. We need a resistor in line there to limit the amount of current that's going to the LED. Otherwise, too much current may go to the LED and then we'll smoke it. Okay, so I don't know if you can make this out. Let me move this lead here. So you might just be able to make out that positive is going into that terminal right there. And then I've got my resistor in line with it right there. Okay, if my resistor was over 1, so if my resistor was over 1 like that, then there won't be any continuity and no current will flow in the circuit there. So just make sure that everything is lined up there. And depending on your breadboard, it may be tighter or looser than mine. So sometimes it's a pain. You got to push it right in there. Okay, so now we have the positive going to the resistor. Now I got to put my LED in line there. So I'm going to put the positive on, let's see, that would be your right hand side. I'm going to put the positive on the right hand side and the negative on the left hand side there. Okay, then I just need a jumper to go back to my negative bus there. So you can make, like some people like make it really tight where everything's kind of jumpered off of these two terminals here. It's totally up to you how you want to set it up. The negative of my, or the cathode of my LED is right there in line with that terminal there. So I'm going to bring that guy, and I got to make sure that I don't short out my supply. I'm going to bring that to the negative bus bar there. Beautiful. Let's move these guys over so we can see the LED there. So simple circuit here. We've got the positive going, or the 5 volts going over to the positive bus bar. Then from there, we went to our current limiting resistor. And from the current limiting resistor, then we're going to our LED. And the cathode, or the shorter side of the LED, is going back to the negative there. And the negative has been tied into the ground on the Arduino. Okay. The components that come in your kit, so where you're grabbing that LED, you have two components. You have a bag here of resistors, and you have all different types of resistors that are in there. Get that in a shot. And you've also got, if you grab the most complete starter kit, then you have a box like this, and part of that has the LEDs in the top corner there. Okay, this is pretty good in that the LEDs are separated. If you have the smaller kit, the super starter kit, then everything's kind of jammed in together. What I do is, because I like to separate all my components, so those LEDs are fine in that plastic container, but I like to use little envelopes. So I keep all my LEDs in one envelope, and then because there are a disgusting amount of resistors in there, and you'll notice that they're all blue, right? So my eyes are already going, so I can't tell any color code there whatsoever. So I can't discern one resistor from the other. So what I do is I separate all my resistors and I put them into just a Ziploc bag. And then I put them again into these little envelopes. And so I have all my 220s in there. And if I need a 5K, then I've got an envelope for the 5K resistors there. And then they all just go into a Ziploc bag here, so I can grab it at any point there. Okay, then I've also got my leads, because you'll find that your leads are maybe going everywhere. So I put all my leads into a Ziploc bag as well, and then I can just grab them. I have leads from different kits, so I just throw them all in there. And then when one breaks, I got lots as replacements there. Excellent. Okay, so hopefully everything's making sense so far. We've set up our circuit here. Let's get into the code now. Now, how did I know that the longer lead? Well, you can do a quick Google search, or in that the Lego kit, this is 2.1 for the LED. Now, for this exercise, they're simply just having you set up between the 5 volts and the ground. And they're having you put in the 220 ohm, then I believe a 5K, and then a 10K to see how much current is flowing through the LED. But this one will set you up and tell you everything about the polarity of the LED, and that the longer lead is the positive there. Okay, they do have a color code on them, and you can read up on how to discern what the color code means with the first, the second, the third, and then the multiplier there. But I can't see those color codes. So on the actual resistors, you will notice that they should have stamped. Let's see if they do have stamped here. They should have stamped the value there. Yes. Okay, so you might be able just to make out here. Let me go back to this guy. So you might just be able to make out here 100K there. But as soon as you remove one of these resistors from this set here, well, then you have no idea what value that is. And then you'll have to use your ohm meter to try to figure that out. So I do find that taking these guys, throwing them into an envelope and having them labeled properly really reduces the time that I need to grab a resistor. Now, every time that you have an LED, you are going to need to use that 220 ohm or the 330 ohm. You can use a higher resistance, but if you use a higher resistance, then you're going to have less current in the circuit. And so less current will mean that your LED will be dimmer. So 220 or 330 is good, just so we don't smoke that LED. Okay, so let's get into our first program here. Okay, so we've got our circuit set up now. Now, just keep in mind that we don't have our power or our 5 volts coming from an output terminal right now, like on the top there, any of the pin 0 through 13. We simply have the 5 volts going to one side of the circuit and then ground on the other side of the circuit. So this is a quick and easy way to test out your components, just to make sure that that LED is not burnt out. So I'm just going to hook it up to my computer now. And as soon as it has the 5 volts from the USB, you can see that my LED is nice and bright now. Okay, but it's not flashing. If we have that previous program, which you probably still have as well, then you'll see that pin 13 right here has that integral LED, and it's still flashing at the rate that we left it at from the previous circuit there. So right now we're good. We can see that the LED is bright and does have current. If I take this bad boy out and put it in the opposite polarity, then you'll see that everything was set up nicely, but the LED does not light up now. So it needs to have that polarity in that the longer lead goes to the positive and the shorter lead goes to the negative, and then it'll light up. Now see, it looks like I have it in the circuit, but I need to move my positive lead over one more. So just be careful. There's the two things that'll screw up: the polarity of the LED, and then just missing by one terminal on the board there. So we want to test out sometimes between whether it's a hardware issue or whether it's a software issue. Okay, then if this guy is getting its 5 volts directly from the 5 volts, I can move this over to pin 13, and my program will be sequentially powering that pin 13 up and then turning it off. Cool. So now you can see that both LEDs are illuminating at the exact same time, being this integral LED and the one that we just hooked up there. Excellent. So that is the blink, right? But we just, on the previous one with the blink, we just grabbed it from the examples there and then downloaded it downloaded it to our Arduino. What we need to do is we need to slowly just walk through that Blink program, and we'll see how changing some variables will be able to change that delay time as well. So let's bring up our Arduino, and we'll slowly walk through how to create this Blink program here. All right, guys, so let's start off. The first thing we're going to do is we're going to open up what's called the bare minimum. So you can just open up a new program, or you can open up the bare minimum. So that is found in File, Examples, Basics, and then Easy Now, and then bare minimum. Okay, so that will bring up just your base Arduino program here with the void setup and the void loop. So the first thing we need to do is we need to create what's called some integers. So there's a number of different things that we can make use of. There's integers, there's floats, there's strings. Integers are just whole values or whole numbers, whereas a float would have a decimal place. Float and real are very much the same. And then we have strings, which are just words. So we're going to make use of integers at this point. We just need a whole number. And what do we need an integer for? We need an integer for the LED pin. So I'm just going to type in LED pin. So I'm creating a global variable that I'm going to make use of later on in my program there. And I'm going to make that equal to pin 13. And then remember that every line needs a semicolon there. Now you'll notice that I've put in these spaces here. Let's just verify this program here and see if there's an issue. So it doesn't seem like space, like when you put a space into the Arduino program, that it minds it. I like to just leave the spaces out, but just keep in mind that the spaces don't seem to matter. So if I verify this again, everything seems cool on the bottom there. Okay, so what I've done is I've created a global variable, LED pin, and I've set that to pin 13. Okay, I'm going to make use of that later on in my program. Then I want another integer because I want it to be able to change my delay time by just changing once the value at the top, right here my variables, and that will change all of my values below. So I'm just going to put delay time, and we'll start off with 1,000 seconds, just like we had before. Okay, we'll put a space in there between our variables here and our void setup, but that's basically set up. We have set up an integer for LED pin, making it pin 13, and we've set up a delay time, and that global variable is just dt, and we've set it to 1,000 milliseconds there. Okay. Then we move on to the void setup. Remember, the void setup runs once, and that's it. So what I need to do is I need to say what my pin 13 is. Is it an input or is it an output? So you'll notice here that I made use of what's called bumpy text, and that I have lowercase LED, and then the next word, the first letter of that word, is in an uppercase. So that's called bumpy text. You'll see the same thing here in pin mode. So if I change this to a lowercase m, then it no longer goes orange. So we're going to keep that as an uppercase M, just the same as we have for the bumpy text there. And then the pin mode, what do I want to do? I want to say that my LED pin, so I'm not saying pin 13 because I've already declared LED pin to be 13 above, and I want that guy to be declared as an output. Okay, you'll notice that for the output, it has to be uppercase. Again, if I did this in lowercase, then it is not blue. So you'll see that within the Arduino, it will give us color codes to tell us that we're not screwing anything up and that we have the right syntax there. I'm going to close that bracket there. Come on, Pete. And then at the end of there, I need to have a semicolon. Excellent. So that's all I need to do. I just need to do once. And I need to say that that pin 13, is actually an output there. So you can change any of the 13 pins from being an input to an output, but you have to do that using the pin mode. Okay. The reason why we didn't have to do that in the previous Blink was that they had something in the program where the internal LED was already tied in with pin 13. But normally you have to do a pin mode and set your pins as either an input or an output. Okay, we've done that once, and then we can move on to the void loop. So what we want to do for the void loop is we want to do what's called a digital write. So there's my lowercase. My next word is going to start with an uppercase letter. So I'm going to do a digital write. Again, if I did all lowercase, then it's not coming in orange. So I know that I have the syntax wrong. So I have digital write. And then what do I want to do? And so digital write means that I want to basically turn something on or off, right? Digital just means a 0 or a 1, 0 volts or 5 volts, on or off, right? So completely different than analog there. So I want to do a digital write. I've created that global variable for my LED pin, which is tied into pin 13. So I want to do LED pin, and what do I want to do with that? I want to write it high. High meaning I want to have 5 volts going to that LED. Okay, again, I've said it numerous times, but you'll see within my videos, I usually say things 3 times. So I need to put this in as capitals there. And if you were bored with the beginning part where I was just setting up the LED and you want to just jump to the code, then I will always have, or if I forget, you'll remind me, I'll always have something in the comment section where it says the code is available at this, like 4 minutes and 23 seconds, right? Because I always talk way too much in the beginning and then I get into the code, or I may go over how to actually wire something up. So if you want just the code, then there'll always be a link there within the comment section. Okay, so I want to do an LED pin high. I don't want to forget that semicolon at the back there. And then what I wanted to do is I wanted to do a delay. You can see that as soon as I typed in delay, that it went orange. So that's a specific instruction within the Arduino programming. And how long do I want to delay for? Well, I just want to delay for my delay time, which is set up here for 1,000 milliseconds. And at the end of that line, I need to put my semicolon. Sweet. So remember that this void loop happens at a disgusting rate. So we need to put in a little bit of delay. Otherwise, it'll just go high, low, high, low, high, low, and we won't be able to discern the on and off on the LED there. Okay, I'm going to do the exact same thing below. So I'm going to copy those guys and paste them in. And the next thing I want to do is I want to put in low. And I'm going to keep the delay time the same. So you can see here that once you have a global variable at the top here, at 1,000 for DT, then each of these values will be set to that same value. If I wanted to change it, I just have to change it once at the top there. Comments are always good, so I can put in a comment there with a double slash. And for this guy, this is going to be 5 volts to the LED. And then here, this guy is going to send 0 volts to the LED. Okay, so as much or as little comments as you feel is appropriate there. But the comments are there for you for later to remember what you were doing in that program. And then if you're putting this on the net, then it provides everybody else with a little bit of background as to what each line of code is actually doing there. Okay, I think we're set up. Let's do a verify here. So we'll compile. Beauty, everything's good. Let's download to or upload to the Arduino. Beautiful. There we go. And then we can see that the LED is now flashing at that 1,000 seconds or 1,000 milliseconds, sorry, for the on and off there. So let's change that delay time. Let's change it to 500 milliseconds. Now I've made a software change. The hardware does not see that yet. So I need to upload that, and you'll see that the frequency of the LED now changes. So hopefully you're seeing that I can easily change the value for my delay time just once, and it changes both the on and the off now. So now we're on for 5 seconds and then off for 5 seconds. Beautiful. Okay, I'm going to go back to 1,000 milliseconds. So changes are quick like that, right? Boom, send it over, and it changes to 1,000 milliseconds. Now I've arbitrarily chosen this pin 13 because we were using that with the internal LED, but maybe I want to use pin 13 for something else, and I want this LED to be connected up to pin 2. I just have to change that once, and that changes all of these guys, all 3 of them, to pin 2. Okay, let's upload that to the Arduino. Okay, and at that point the LED is not firing on because I'm still connected up to pin 13. So let's move this over to pin 2, 0, 1, 2. Beautiful, and now the program is firing on pin 2 at a rate of 1,000 milliseconds being on and off. Sweet. Okay, maybe I want to change this delay time, but I want to have a delay time on, and I also want to have a delay time off. Okay, so you'll notice, so just keep in mind, like I've just, by mistake, put them both capitals. It has to be exactly the same later on in my program. So just try and keep with some nuance there that's the same, right? So I would probably go like this to stay with the same thing as we had before. Otherwise, I'll probably screw it up later on in the program there. So I want to have my delay time on as 1,000 and I want to have my delay time off as 2000. So now I can change the timing being on and off. If I then verify this, then you'll see that on below it says that DT wasn't declared. So it was there before, but I've changed it to DT on and DT off now. So I have to accommodate that below. So this guy would most likely be my delay time on. Okay, and this guy would be my delay time off. Okay, let's verify that and make sure that everything is cool. Sweet. Okay, if I had made a mistake and kept that as capitals, and I had declared my DT off up here with just one capital there for the second word, then when I verify it, then it'll say DT off isn't declared. So you'll see that just those minor variations between the variables and the variables below will screw up your program. Excellent. So let's upload this to our Arduino. We're still on pin 2 there now. So it should be on for a second and then off for 2 seconds. On for a second, then off for 2 seconds. Beautiful. Then I can change those guys up. I want to be on for 5 seconds. I want to be off for 1 second. Quick change. And that's over to the Arduino. And we see that change live there, being on for 5 seconds and off for 1 second. Beautiful. All right, guys, hopefully everything's worked out so far. Hopefully you're understanding that there are basically 3 parts to the program. The beginning part where we set our global variables. The second part, which is the void setup, that runs once and only once. And then the void loop, which continuously runs over and over and over at a disgusting rate of speed. So oftentimes we need to put in a delay there just to slow it down so we can see those changes taking place. Any comments that we want to put in there, we're going to be doing the double slash mark. And then the Arduino just completely negates that. And every line is essential that we have the semicolon at the back there. If we lose a semicolon, then it's not going to like it, right? And it'll tell us that it expected that semicolon before the void, right? Excellent. So hopefully everything's working out so far. Hopefully you're liking the setup here. You'll give me some feedback on the audio, whether I'm looking at the camera an appropriate amount of times or whether you're just looking at the side of my head here. So this is my third video in this playlist. So give me lots of feedback. Tell me which things to change. I had done some previous Arduino videos before, but the audio sucked. So I've kind of just erased those guys and I'm now starting fresh. So I really need your input as to what things you're looking for me to change, whether you want me to make it more concise and stop talking, which I don't know if is possible because I have a little bit of verbal diarrhea here. Yeah, what things are you looking for within this playlist? And as we go, you're going to be like, okay, well, that's cool. I like what you've done so far, but I'm really hoping that you're going to get to this sensor or you're going to cover this topic. So provide me with as much feedback as possible, and then I'll make sure that the playlist matches with the way that you'd like to learn. All right, guys, thanks very much for your patience, and I'll see you in the next video.